Hi everyone. Here we have section C of the CAPE 2018 Integrated Math past paper. Okay, first question says, function f is defined by f of x as follows, and they want us to find the value of a for which the function is continuous at x equals 1. Now, if the function is continuous at x equals 1, that means that the limit exists. And if the limit exists, then the right and the left are the same. Now, here we have the domain for when x is greater than or equal to -1. So this right limit can be found. So if I go ahead and find the right hand limit by plugging -1 in place of the x, I get that to be 5. Once again, if the limit exists, then both the left and the right are the same. So if this right limit is 5, then the left limit is also 5. So all we have to simply do is equate this domain for the left limit to 5. Now, so the limit as x approaches 1, -1 from the left is equal to 5. So plugging -1 to the 4 minus a equal 5 from our left limit, we can solve for a. If we raise -1 to the power 4, we get a +1. So a is now 1 minus 5, which is -4. For this question, it says y equals 3 cos x ln x. We have two functions being multiplied, so we're going to be using the product rule. First function u is 3 cos x, and second function v is ln x. So plugging in u, 3 cos x, differentiate our v function, so derivative of ln x is 1 over x, plus v, which is ln x, and if we differentiate the u function of 3 cos x, we get -3 sin x. We can now simplify and get 3 cos x times 1 over x, and this plus and minus makes it a -3 ln x sin x. For this function, we have 2 being divided, so we'll be using the quotient rule to differentiate this function. Here we have the quotient rule, so we're going to go ahead and plug. First, we put our v function, which is sin x. Now, the top function is u and the bottom function is v. So we put our v function, sin x, du dx means we differentiate the u. This will give us 5e to the 5x minus sin u, which is e to the 5x. And now dv means we differentiate the v function of sin x to give us a positive cos x. All of that goes over v squared, which is sin x all squared. To simplify, I factored out what's common, which is e to the 5x, to be left with 5 sin x minus cos x, and that all goes over our sin squared x. Here, we need a partial derivative with respect to y, which means we are going to differentiate the y components of our function, and the x's are going to act as constant. So if we differentiate this x, which is acting as a constant, we'll get 0. Differentiate 2y, we get 2. Now we have xy here raised to the power 3. We're going to apply the power rule. So get power times coefficient is 3. Write back what's in bracket. Subtract 1 from the power to get 2. And when we differentiate the bracket, find a partial derivative of the function with respect to y, we'll be differentiating this y to get 1, and so we left with x. 1 times x, which is x. So simplified, our answer is 2 plus 3x times xy all raised to the power of 2. Next question. We have our function f of x as seen, and they want us to find the critical values, also known as the stationary points. The stationary points occur where the derivative is equal to 0. So we will therefore find that derivative and equate it to 0 to find those x values. If we differentiate our function, we'll get 6x minus 30x plus 36 as seen here. Now what I did was simplify our function by dividing each value by 6 to make it easier to work with. So now we have 1 times 6, which is 6, and the factors to give us this negative 5 will be negative 2x and negative 3x. So factoring out the common value of x, we'll be left with x minus 2. Here, factoring out a negative 3, once again we're left with x minus 2. So our factors are x minus 2 and x minus 3 equals 0, making our x values a positive 2 and a positive 3. So we have found the x values. We can now find the corresponding y values. We will do so by plugging each of them into the y function and evaluating that answer. For here, when x is equal to 2, we get y to be 4, and when x is equal to 3, we get y to be 3. So here are our stationary points or critical values, 2, 4, and 3, 3. The next part of the question wants us to determine the nature of these stationary points. One way of doing so is from the second derivative. Now, if the second derivative is positive, it's a minimum point, and if it is negative, it is a maximum point. So we're going to take each stationary point and plug into the derivative, the second derivative. Now, when x is equal to, first of all, we need to find that second derivative. dy dx was equal to 6x squared minus 30x plus 36. 6x squared minus 30x plus 36. Now, even though I went and simplified this function to get this below, that's not the derivative. We have to go back to our original function, which was the derivative. So we will now plug our x values into the second derivative, which was 12x minus 30. When x is equal to 2, we get 24 minus 30, which is a negative 6. Since it's negative, this stationary point is at a maximum. When x is 3, when plugged into the second derivative, 3 12 36 minus 30 is a positive 6, making this stationary point a minimum. Next question wants us to determine the following indefinite integrals. So here we have the integral of 4 plus sine 5x. We integrate each separately. If we integrate 4, we'll get 4x, and if we integrate sine 5x, we'll get negative 1 over 5 cos 5x, and our plus c goes at the end. For this question, we have the integral of 1 over root 2x plus 1. Now this root 2x plus 1 is the same as being raised to a half. So when it is brought up at the numerator, it's now raised to a negative half. Now for us to integrate this function, we'll be applying the linear factor method. So we add 1 to the power, or 2 over 2, to get half, and we divide by that half. Now before we go further, we have to now multiply it by the coefficient of x, which is 2. So 2 times half is 1, making our answer simply 2x plus 1 raised to the half plus c. Here, it wants us to evaluate the definite integral of negative 2 to 0 of our function x squared plus 3x. So in this case, we're going to integrate our f of x, and whatever answer we get, we're going to plug our upper and lower limit, then subtract the values. Now if we integrate x squared, we'll get x cubed over 3, and if we integrate 3x, we get 3x squared over 2. Because add 1 to this power, we get 3 divided by 3, add 1 to this power, we get 2 and divide by 2. So this is our integral in which we're going to plug our upper and lower limit. The upper limit is 0, so when plugged anywhere in place of x, that will give us a 0. Write our minus sign. Now for the lower limit, we're going to plug negative 2 in place of the x's. Negative 2 cubed is a negative 8, giving us negative 8 over 3, plus sign. Negative 2 squared is a positive 4. 4 3s is 12, and 12 divided by 2 is 6. So if we add 6 to negative 8 over 3, we will get 10 over 3. And this negative sign makes it a negative 10 over 3 overall. Let's go again. This is the integral in which we are going to plug our upper and lower limit. So the upper limit is 0, which we will plug in place of the x's. Anywhere plugged will give us 0. Minus sign. Now for the lower bracket, negative 2 in place of the x's. Negative 2 cubed is negative 8, giving us negative 8 over 3. Negative 2 squared is a positive 4. 4 3 is 12, and divided by 2 gives us 6. Now negative 8 over 3 plus 6 gives us a 10 over 3, making our answer a negative 10 over 3 because of the negative sign that was already here. Now this question, the second part, wants us to shade the region that corresponds to the definite integral that we did earlier. And since it was from negative 2 to 0, that is because we found the definite integral from negative 2 to 0, that is where we will shade for this question. So all of this gets shaded. Now if you recall, our answer was negative 10 over 3. And that's why the reason it's negative is because that portion is below this x-axis. Next question says, briefly explain the relationship between differentiation and integration. Now simply differentiation gives the gradient of the curve, while integration can give the equation of the curve. Now, next question says, solve the differential equation. To solve a differential equation, we have to first separate our variables, then integrate each side. So, this y will be brought over as 1 over y, and this dx will be brought up. So now our y's are grouped, and so are our x's. So now we can integrate each side. If we integrate 1 over y with respect to y, we get ln y. If we integrate x with respect to, if we integrate x, we get x squared over 2 plus c. So this right here is our answer. For this last part, it says, obtain the solution for the function y that passes through the point 0, 10. So x is 0 and y is 10. We will simply plug that in the correct position. So ln y, or ln 10, is equal to 0 squared plus c. So when we solve for c, it will be equal to ln 10, which works out to 2.3. So now our equation will read ln y equals x squared over 2 plus 2.3.